let's check over here and see if it should start soon. Just take a look. Oh, no, and restarted. Great. And I actually don't want this one, I want this one. Yep, okay. Let's put this on here. And let's plan out what's going to be happening. Let me also put in the chat quickly. Put in the chat. Hey. Hey. When you get, please put our name of Ruben in the chat so I know you're here. That's probably spelled wrong, but that's whatever. That's a new one. Hey, when you get here, please put your name in the chat so I know you're here. Okay. So let's make a plan for what we're doing today. Okay. Plan. So what are the different types of stuff we have? Start off simple. We'll have x times oh yeah, that's not right. We'll have a times a plus b. We will have, actually that's not even the most simple one. Can have a squared a times a plus b, a plus b times a plus b, a minus b times a minus b, a plus b, a minus b, and then should I go into it? Well, a plus b, a times a squared plus a b plus b squared, a plus b, a squared minus ab plus b squared, and a minus b, a squared plus ab plus b squared. Is that visible? That's visible. That's cool. Okay. These are a little bit too big. Plus b, a squared minus ab plus b squared, a squared plus ab plus b squared. No, wrong thing. This is the difference and addition of two cubes. This isn't this. That's that. This is that one. This is a different one. Yeah. Okay, I normally give it like 10 minutes that the stream is on before I start. So we'll wait till then. Is there anything else I can do here? Okay, yeah. I guess. Should I do? Yeah, I will do. A plus b cubed. Okay, I'll do that one. Definitely Go watch like a 5-minute YouTube video or something, and then you can be back. Even though 2 people are actually watching, wonder who. And yes, it's read. You can. They're pretty cool, not gonna lie. Okay, so let me give you a heads up on what this is. Okay, so I'll give you your own little private lesson for now. You can take a seat right here. So, sit down, right there. Okay. What? I listen to music in the background and watch chat. Okay. Oof. Okay, so. Bitch. Okay, so. This is only for you now. Message. Oh, Kate's here. Welcome, Kate. Okay, so this is only for you. Okay, so we've already before spoken about. Look here. Oh, look there. We've already before spoken about variables, right? What's a variable?
We did that quite a long time ago.
So, what's this? What number is this?
An X.
It's an X, but what number is it? What number?
It can be any number.
Any number. Can it be any number or is it all the numbers?
It's all the numbers.
It's actually... Okay, this is actually any number you want it to be?
Yeah.
So what number is it now? Give me a number.
10.
No, it's 5. Okay, so you've got X,
Yes.
but you can also have Y.
Z.
You can also have Z.
A, B, C, D, E, F, G, H.
And you can have all the, and you can actually have more than that. You can have this little symbol here, which that is, it's a Greek letter, yeah, it is. Okay. So, what happens if we add 2 of these together? Like this. What's your answer? You know, this is a number, and this is a number. Are they the same number?
No.
No, they can't be the same number because they have different letters. You don't know what the number is, you show it's different.
Yeah.
What happens when we add a different number to a different number?
We get a different number.
We get a different number. Okay, so we get a different number, right? But we don't know what this number is.
Yeah.
And this number is only this.
Yeah.
But what if we add this number to the same number?
Well,
How many of this number do we have?
2.
So we have 2 of this number,
Yes.
right?
Yes.
Now let's see what happens if we have. What happens if we have not this number plus this number, but this number times this number? How many of these numbers do we have?
2.
2, right? We're not adding them now. Now we have this number, this amount of times, right? What does this remind you of? Remember we did this one. We did this actually with Pythagoras.
Pythagoras. A squared plus B squared.
So what is this? What is A times A?
A times A can be anything. Could be 4 times 4.
No, but only if A is A. We're saying this is A, right? It's still number A.
Yeah.
What is A times A?
A times A is A.
A
Squared.
A squared. Because how many A's do we have here?
2.
And if we have this, A times A times A.
A cubed.
Nice. And what if we have A times B times B? Okay, let's see what happens first if we just have this. A times B. What's A times B?
A times B.
In maths, we can
Yeah.
have a little shortcut, and we can just take away the times sign, just go AB.
AB.
Yeah. So what is this here?
A times.
A times B, right?
Yeah.
Okay. So what does B times B give us?
B times B gives AB.
No, B times B. Only this
Oh,
part.
B times B, B squared.
B squared. And what does A times B squared give us? What happens to the times sign?
AB squared.
AB squared. We have to start. Okay. And that is the quick beginning, and you can now listen to the rest. Okay. So we're starting now, and there are 4 people here, which is enough. Let's start. Okay. Okay. So we're going to be going through all of these. Understand? Yeah? Oh, they're saying hello, Connie. They spelled your name wrong, but it's fine. We'll pretend they spelled it right. Say hello back.
Hello.
Okay. So we have these letters. We have all of these operations here.
Yeah.
And they're not speaking to you. I'm speaking to them now, but it's fine. You can listen. Okay, so we have all these operations here. And there are 2 ways of going about this. You either learn what each one of them gives you, which is easy peasy, no problem. Takes a lot of time. Is the stream still on? Let me give it a...
Yes, it is and it isn't. It's stuck on 11.
Oh, stream resumed. Oh, the stream is continuing.
Okay.
What the hell?
Huh?
What happened here?
Confused.
I don't know. This stuff is...
It's offline.
Yep, stream complete. I wonder what's happening here.
What, they just send it now?
I don't know, it just stopped. Let's see what happened.
Confused. Who's tomatoes?
Technical.
Who's tomatoes? Oh, that's a trust. Who's online?
Okay, so... Okay, let's see video output low. This looks buffering. What the hell?
Can they hear me?
Yes, but wait, don't do that. Yeah, output low. What's going on here? Why is there like no upload? Let's check why there's no upload happening here. Kilobits per second, 0. Settings. Add video output. Note after night to stream. YouTube is currently good. Stream is healthy. Stream health is excellent. Stream. Note the stream. Let me see what's going on here. Hi. Stream. Oh, no, it's fine. Let's see if it's fine now. This should be fine. I don't know why this wasn't working now, but this should be... Oh my gosh. This should be better now. The stream should be better now. Let me see if it gets better. It was good. Hello? Oh, that's better. That's better. Okay, try again. Oh, that's better. Is it back? Oh, that's too loud. Is it back? Let's test. Give me a sign that it's back. Okay, that's cool. So we're back. Can you tell me if it's back or not? I need just a yes. Just give me a yes in the chat. Like one yes.
Yes.
Like a yes. Just give me a yes. That's all I need is a yes.
Anyone.
Okay, cool. Thank you. That's all I needed. Where's the blue marker? There you go. Okay. So, we're back. Let's continue. Okay. So I'm going to start from the beginning now. And we'll go from the beginning from where I started. Okay, so let's do this. Let me just quickly check everything. Put this back over here. But the audio is soft. Let me lift this up. Oh, nope, don't want to do that.
Shaky.
Oh, there's the shot audio. Try now. Is it? Oh, that's way too high. Is it better? Like this? How is it like this? Now, how's it now? How's the audio now? Now is it better? Okay. Okay. Let's go. And ignore the fucking focusing of the camera. Can't do anything about that. That's just the camera. And I'm not gonna get a new one. So, that's life. Okay. So, perfect. Fine. Good. So we're going. So, these are your algebraic expressions and what you can do with them. And so this is them in factorized form. And there are ways of simplifying them out, and this is what we're going to go about doing and seeing how you simplify them. But there are two ways of doing this. The first way is to go through every single one of them and just remember the way it gets factorized out. Actually, this would be like a times a. No, I think about it. Okay, so you could either just learn what each one of them becomes. A times a becomes a squared, a times a plus b becomes a squared plus b plus ab, or you could visualize them and see what happens behind the scenes, and then you can understand what happened to them actually. So if you want to learn the first way, just fucking follow them all out and study what they turn into. What I'm going to be doing is showing you how to look at them visually, so that you can understand what's happening behind the scenes. And maybe when you get to these cubed ones over here, get a little bit of a better understanding at how they work. And I can't draw in 3D, so these are going to be a little bit harder, but these ones are definitely going to be easy to understand, or at least easy to visualize. And then you can learn the formula. But if you don't remember the formula, you can always go back and draw them for yourself, and then you can find them for yourself. Okay, so we'll start with the simplest one, a times a, and let's write it out over here, a times a. I should write like this, okay. A times a. Okay. Let me just also turn the camera this way, because then I'll be standing here, and not there. Okay. So, a times a. We all know that it becomes a squared. Even you, Connie.
Even I.
So, a times a equals a squared. But why? Yes, right, because of exponents, but how do we see this? What does this form the basis of? Because it does form the basis of something. A times a, we can look at it, let me just rewrite it. A times a. We can look at this as a square, finding the area of a rectangle with side A and side A. So if we have a square of side A and another side A, and we just say that it's a square. We know it's a square, you have to put in all the signs and stuff, 90 degrees. It's a square. Side A, side A. What we know is that the area of this square, which is length times breadth, is a squared. Right now, this seems like a redundant step. So this seems like a redundant step. And it really is, because you know that a times a is equal to a squared. But what this helps you understand is through all of these later on, you're able to know why they work. and why this happens. So what we're going to be thinking about is in terms of area and rectangles and squares. Squares, rectangles, and the area of the squares and rectangles. So that's a times a. Very simple, actually pretty stupid, and one of the best things in our lives. If you don't know how a times a works, you're dumber than this. Sitting right here. Ready? No, go back. Thank you. Okay. So, the next one to look at is this. A times A plus B. Why do we distribute? Why does the A go into A and into B? There's no explanation. They just tell us that has to happen. But why? Let's look at it. We can look at this as having a square of a rectangle of side A and the other side being A plus B. A and then B. And if we draw that up into a square and a rectangle, which is like that, what we see is we can find the area of this shape pretty easily. So we know that the area of this square here is just A squared. And that the area of this shape there is just A times B. So you get A, B. If you don't know why it's AB, once again, you're dumber than this. So, what is the area of this overall shape? It's just A squared plus AB. And what we can see, going from here to here, is that all we did was distribute the A out. But now we know why. Because it's the length of one of the sides, and it applies to both A and to B. So we get A squared plus AB. And to factorize it out, we just see the common A, and you take it out. You can also see it as drawing a square here, and a rectangle here, and find that one of the sides is A, and one of the sides is A plus B. It's a long-winded way of factorizing, but it works. So that's another very simple one. It's basically the rule of distribution, distribution. So that's that. And now we're going to get into the more complicated ones, such as A plus B squared. So we can have A plus B times A plus B. And then what we see is that that's just actually A plus B squared. Squared. You see that? Hopefully you can. Okay. A plus B squared. Now what is A plus B squared? And if we look at this, we can see that one side is B plus A, or A plus B, and another side is also A plus B, and then we can finish up this actually is a square, into all these pieces here. And this is where it gets intricate. We find the area of this piece here, which is just A times A, which gives us A squared. Find the area of this piece here, which is A times B, so we get AB. Find the area of this piece here, which is A times B, which gives us AB. And then finally, we get the area of this piece there, this little piece here, which is just B times B. We get B squared. That's not a... We get B squared. And then finally, to find the area of the overall shape, we just add them all up. So we go A squared plus, how many ABs do we have? 1, 2, plus 2 ABs plus B squared. And we figure out that A plus B squared equals A squared plus 2AB plus B squared. And this applies to any two numbers you put in here. By the way, these are just variables, which means A can be X and B can be 3, and this still works. Or A can be Y and B can be X, or A can be 5 and B can be 3. It doesn't matter. These are just variables. These are just general formulas for this. So if you do want to memorize something, memorize this. Memorize that there. But it's much better to understand how you get to this, either by foiling out or by looking at the big square. So you get that. And so that's A plus B squared. Now we'll look at another example. We'll look at, rather than A plus B squared, we'll look at A minus B squared. a minus b squared, which in other words is just equal to a minus b times a minus b. Now, how do we do this? Now, we're not adding two things together. So we don't have a plus b to form one side. We have the whole side a minus this little piece called b. Let's see how that works. Let's create one big side, and we'll call this whole side a. Now, if we want to take away b from it, we'll take a little portion of a and call that b. And so the a minus b is this little piece here. And I can just label that as a minus b. So this piece here is a minus b, this piece here is b, and this whole line, this whole side is a. Do the same thing with the other side because it's identical, a minus b. So this whole side is a. We can have a little piece called b, and then we can have this other piece here be a minus b. Now we want to find what a minus b squared is. So the area of a minus b. Let's draw in the lines to complete the square. And this isn't complete the square from AP Maths, this is just squared. But we want only this area. So you have to minus out this, this, and this. So we'll do, what's this area here? B times b, which is b squared. What's this area here? This whole area of this whole thing. This whole area of this whole thing. The area of that is a times b. So the area of this whole thing is ab, and this encompasses this whole thing, not only that one little piece there. And the area of this is also b times a, so it's ab, and this also takes up this whole area. So if we want to minus, if we want to find this area here, we can minus out one ab and a second ab, so minus out two ab's. What you notice is you're minusing out this area here, and then you're minusing out this area here. Which means that you've minused out this little piece here, b squared. You've minused it out twice. And that means you're losing one b squared from this whole piece, which isn't good. You only want one b squared taken away, which is taken away two. So what do? You add one back. So you've taken away one of these, another one of these, but because you've taken away one too many of these b squareds, you add one back in. And that's how you get this formula here from this. And that's that. That's a minus b squared. That's a minus b squared. So, all good for now. If there are any questions, once again, just pop them in there and I'll take a look at them if I see them. So that was a minus b squared. We've done a plus b squared. We've done a times a plus b. We've done a squared. Now we're on to the most complex one of these two-dimensional shapes, and that is, what is a plus b times a minus b? More commonly known to you guys as difference of two squares. What is a plus b times a minus b? You cannot group them into one thing squared, so it's a plus b times a minus b. We'll use the same formula, the same things as before, to try to figure out what they are. So we want, what do? We have one side called a plus b. So you have a little piece here called b, you have a little piece here called a. You have one side called a minus b. So we'll have a, we'll have a little piece in there called b, same size as b up there, because they're the same. We want to find out what's the area. So you have a plus b times a minus b. We want to figure out the area of a plus b, this, times a minus b, which is this. So we want the area of this piece here, this whole piece here. So a plus b times a minus b, this piece here. We want the area of this. How do we get to that? Well, we have the original a plus b times a, right? What we get is we have a plus b times a. That is this piece, a plus b times a. That is this whole shape. And that is this whole shape. From the whole shape, we want to minus out this and that. So what is this piece here? This piece here is AB. This piece here is B squared. What do? We go A plus B times A minus AB minus B squared. What do we get? What's A plus B times A? We did before. We get A squared plus AB minus AB minus B squared. So we take this AB and that AB cancel, and we're left with A squared minus B squared, which is your difference of two squares coming from this formula here using the square. And that is that. That is your two-dimensional shapes. And they're two-dimensional because your highest exponent is 2. This one is the most confusing. BA plus BA minus B, your difference of two squares. So if you want, I can explain it again. I just need to know. Let me see. And if everything's fine, after a couple of seconds, I'll continue. Everything seems to be fine, so I'll continue. I'm going to slot in one more over here, in between these two, and I'm going to call it A cubed, or A times A times A, because that's similar to this over here. It's starting off a new section, so that's right over here. So what is A times A times A? Well, it gives us, we want the volume of this shape, not because it's three-dimensional. So we have A times A, you draw in the square, and then with a length outwards of A. And if we finish this off, we draw off the rest of the cube, then we get that the volume of this cube is just A times A times A, then you get A cubed. And that's simple, not that hard, and pretty stupid, but it's just a way of starting it off. So we have that. Next, what we want to see is what is A times A squared plus AB plus B squared. Now, why this specific set of numbers, A squared plus AB plus B squared? To be honest, because they work with these. Why you use this shape here and why this exact shape works, I don't have an explanation for. But all you just have to know is that it's literally put an A here, put an A here, put a B here, put a B here, and then go 2, 1 for both, 2. That's it. And then this is always a plus there, this is always a plus there, and here in the middle, it depends. So what does this give us? Well, firstly, we want to figure out what this shape is. What this overall shape is. A squared plus AB plus B squared. What is the shape? So to help us, let's start off with A squared minus AB plus B squared. Because that's easier to work with. Now we know from the earlier examples that whenever we have A squared minus something, all of our area has to be A squared. Meaning that this is A and that this is A. Now we want to minus out of this area an AB. So what we do is we can add them to one of the sides in a B. We have a B squared there as well. That means at some point there's an intersection of B squared. So there's another B here. We draw in those lines, and we get the shape to be A squared minus AB. So this is first drawing, this is B squared. This whole thing here is AB. This whole thing here is AB. So we're going to go AB all the way across. throughout the whole thing, and then AB here as well, all the way up and all the way down. And we're only looking at this now. What is that? So, we want a squared minus ab plus b. So what is a squared? We want this whole thing. And what's left, when we minus out one ab, one of these ab strips, but we add back a b squared. Means if we minus out an ab strip, we take this out, but then we're adding back a b squared. We're adding that back in there. And this is the length b here, but this is the shape we're left with. We're left with this wonky shape, which isn't totally a rectangle and isn't totally a square. It's actually not even a quadrilateral. It's a 1, 2, 3, 4, 5, 6-lateral, hectalateral. So, I can count. Okay, so we have this shape here. This is our shape. This is a squared minus ab plus b squared. This is this shape. Now we want, what happens when we multiply this whole shape by a? And by the way, what was the area here? Well, this was a minus b. This was b. This was a. But then this whole thing was a. And this was also a minus b. Well, this whole thing was also a. This was b. So this is a minus b. And this is a minus b. So this area is a minus b squared. We already said it was a squared minus 2ab plus b squared. That's the area there. I'm just going to write it out as a minus b squared. And that's what we looked at it first, because it's important for later on. A minus b squared. So you have this shape here. A minus b squared plus ab. This actually isn't b squared anymore. This is just, yeah, b squared. Okay. So a minus b squared plus ab minus ab plus a b squared. That's what I want. Okay. So, what happens if we multiply it by a? We're adding the third dimension, so we're going outwards. There's the a, there's the a, there's the a, there's the a, and we're left with this nice shape here. Then we can just draw this line going upwards like that. Actually, it's not connecting there exactly. It's a little more outwards. Like that. And this is of length a. And this is of length a as well. Ooh. A. That's of length a as well. Which leaves us with the volume of this shape at the top here, which is AB. It's just AB. Because we added back the b squared, but it's just AB. You know, the whole thing is AB. So it's AB times A. So the volume of this whole shape here is A squared B. And then we have A minus B squared times A, or the volume of this shape here, which is just A minus B squared. And if we add them together, we get A squared B plus A minus B squared. What is A minus B squared? It's A squared minus 2AB plus B squared. Plus B squared, I'm drawing writing skew now, plus B squared times A plus A squared B. We can then substitute the A back into there, so we get A cubed. So we get A cubed minus 2A squared B plus AB squared plus A squared B. I think it's A back right in there. Which we take the A squared B, put it into there, left with A cubed minus A squared B plus AB squared. And if we shift from the beginning, substitute the A into there, we get A cubed minus a squared b plus ab squared. That's what answer we got. So we know it works. This is a horrible method for 3 dimensions. It takes lots of time and you want them to finish the test. But it's a good thing to see it once so you can understand how it works. Okay. So, that was that. Now we'll move on to the complicated ones, but that turn out to be very, very, very nice, and they simplify it very well. They are the ones with the cubes. And you don't see it yet, but you will see it at the end. It's these two. These two formulas. And for the one person that's here, I don't know who that is. For the one person that's here, these two formulas, if you don't remember them, they'll come and fucking kill you. Because you'll die if you don't know these. So, the first one. A plus b times a squared minus ab plus b squared. Okay? Now we know what this is. We did it before. This gives us a shape like this. A shape like this of ab and then a minus b squared. If you don't know how I got to that, you can go earlier and check because I did it like 5 seconds ago. This. It gives you that. Then we're multiplying by a plus b. It's in 3 dimensions. So we extend out a plus b. And we can say that this is a and this is b. We can draw the b line going all the way through, right through there like that. And this is b. This is b. And this here is a. Now once again, the thing we do one more time is we go ab times a gives us a squared b. ab times b gives us ab squared. A minus b squared times a gives us a minus b squared. And then this one is b, a minus b squared. Remember, we're just multiplying it out, multiplying the face by the length of the volume going outwards. Because we know this is the area of the one face, so it's just multiplied by them going outwards, and that's fine. You get that. Now we just add them all together. We have ab squared plus a squared b, this one, and we'll add in plus a times a minus b squared plus b a minus b squared. Okay? Now what we do, ab squared, so we leave these out, we'll solve these, so we're left with ab squared plus a squared b, do that quickly, then we'll get this, just plus. You know it's going to be a squared, so we're going to put a cubed. So it's going to be negative 2ab, so it's negative 2a squared b, negative ab squared. We just put the a into there immediately, and then this once again, plus b times a squared, which is a squared b, minus, I'll stand in front of it and you'll see it now, minus 2ab squared plus b cubed. This is the big thing we have here. It's daunting. It's scary. But watch this. This is where it gets cool. ab squared. We have a negative 2ab squared here. So we've got ab squared and then and the negative ab squared there. This one cancels with this one. We have a positive a squared b here, and we have a negative a squared. Oh, never mind. Wait. I have a positive a squared b here. I have a positive a squared b here, and we have here a negative 2a squared b, positive a squared b, and plus a positive a squared b gives us 2a squared b, 2a squared b minus 2a squared b. This cancels out with this and this. If you can't see why, look at it again, you'll figure it out. Then we're left with negative 2a squared b. I think I'm missing a term here. I don't know why this isn't cancelling out perfectly. I think I'm missing a term. I don't know who's still here, but you just saw me mess up. Why am I missing a term? Let's look at this again. Let's look at this again. So, what we're going to do is go ab squared plus a squared b plus a cubed minus 2a squared b plus ab squared plus a squared b, and I'll continue over here, minus 2ab squared plus b cubed. How's it away too? You're like the only person here. So thanks for being here. And I'm gonna fucking teach you more than this. So you're gonna fucking get like gang marks tomorrow. Let's see. ab squared plus ab squared leaves us with 2ab squared. Then we have a minus 2ab squared here. So this cancels out with this, cancels out with this. You get that? Because it's ab squared plus ab squared gives us 2ab squared. 2ab squared minus 2ab squared gives us 0. Perfect. A squared b plus a squared b, there we go, gives us 2a squared b. 2a squared b minus 2a squared b cancels out. And then we're left with a cubed plus b cubed. So we have a cubed plus b cubed. Perfect. A cubed plus b cubed. This whole thing, this whole mess, left us with this. Whoops. Simple answer. And that is what people don't know. They don't know that this mess gives you this. And you literally need 0 working out. Because it's an identity. Now what I'm going to do for all of these is I'm going to write out the answer next to them. Equals a squared equals a squared plus ab equals a squared plus 2ab plus b squared. This is equal to a squared minus 2ab plus b squared. This is equal to a squared minus b squared. Put that meter. A squared minus b squared. But what you can do afterwards is you can take a screenshot of this here, and then just like memorize it if you want. But this is more important. Understanding it is more important than memorizing it. We've got a. This just leaves it with a. This is just substituting in. So I'm not going to put the answer. For this, let me just erase all this now. So let me just write out the answer in meter here. So what we got here for this whole mess, we did this first. So we got, this is equal to a cubed plus b cubed. That's just a simple answer, but it's great. And this one is equal to a cubed plus a squared b plus ab squared. And this one we'll do now. A minus b times a squared plus ab plus b squared. And you can expect from this one already, from knowing from this one will also give you a very simple answer, because it's also an identity. And you can guess that if the sign is different here, that it's also going to be different over here. So it'll probably be a cubed minus b cubed. But we don't know that yet. We haven't tested it, and in maths, you don't guess. Even if you don't know. You just try. Let's do it. This one now. We'll go. A minus b times a squared plus ab plus b squared. Now what do you get out of that? Let's see. We already know this, we haven't done yet now. We have to calculate this now. Let's do it. Let's calculate that. It's pretty simple, except this time we have a squared. So we can add now a. Add now a here. Add now two a's, actually, because it's a squared. It's a and a, so this is a squared. Plus ab. Therefore, we can add a b in here. Add a b in here. So it's plus ab plus this little piece here. And then it's plus a b squared. So what we're doing, we're just going to add in a b squared over here. And we'll say this is a b. B squared. Know what this reminds me of? This is extremely similar to what we had here, except instead of having this whole thing be AB, now it's AB plus B squared. So instead of this whole thing being AB and this being A minus B squared, this is now A squared and this is AB and this is B squared. So not no more A minus B squared. It's much simpler ones now. So they work better. Now, let's try again. What are we extending it by? We're extending it by A minus B, right? This time, I'll extend it downwards. Extend it downwards, because there's more space downwards. So this will go out here. Make it longer, because it's A minus B. This will go out here. This will go out here. This will go here. And this will go here. We can close these up. And then, all we get is this. This whole side here is A. This whole side here is A. Or we can make, because it's A minus B, this little piece in here, so very similar to before, B. Therefore, A minus B is only this piece in here. The piece, so let's draw the lines in. Where this is B, and this is B, and this whole thing is A. Not very much to scale, but it is. That's what it is. So what we're going to get is this. We're going to get, remember, this. Oh, and I'm going to draw the lines up here as well. This is also pretty important. Line here. There we go. Now we have the A squared. If we find the volume of this whole thing, of this whole strip here, then we can get the volume of this little block in there by minusing out this block. So what is A squared times the volume of this whole thing? Well, it's A squared times A. So it's A cubed. Minus A squared times B. Minus A squared B. That is the volume of this little cube in there. We can call this X. That's X in there. Because it's going to get very messy. Then we can say AB, once again, times this whole thing is A. So we can say it's A squared B minus only this little piece here. This little piece over here, which leaves us with AB times B minus AB squared. And we can call this little piece in here Y. So we can say that's Y. Y equals that. Remember, because we're minusing here, we only want the strip in here. Focus. Okay. So, since we have Y, there's a little plus piece in here, we can call Z. So we can say Z equals A times B squared, same thing, AB squared, and then B squared times B because it's B cubed, so minus B cubed. And then what we can do is we just have to add them all together. That's the thing. X plus Y plus Z, so it's A cubed minus A squared B plus A squared B minus AB squared, and then it's plus AB squared minus b cubed, and it's all right in front of you. All you do, cancel out these two, you're left with a cubed minus b cubed. Therefore, you can erase this whole thing now. Therefore, a minus b times a squared plus b squared is equal to a cubed minus b cubed. And these formulas, you need to remember, because I can guarantee they'll ask you at least one of these. And they'll be worth 4 marks or 5 marks. And it's easy. If there's a plus there, there's a plus there. If there's a minus there, there's a minus in the answer. If there's a plus in the smaller bracket, there's a minus in the bigger bracket. If there's a minus in the smaller bracket, there's a plus in the bigger bracket. That's how it works. And it's as easy as that. And remember, it's not minus 2ab or plus 2ab. That's only for these. Over here, those 2's don't exist. Why? Just think about this. If there isn't a 2 on the top here, because it's going to be written as a plus b squared, then there isn't a 2 inside. So here there isn't a 2, you can't rewrite this as a plus b squared, and there isn't a 2 on the inside. Here you can write it as a plus b squared, so there's a 2 on the inside. And finally, just for the fun of it, this probably won't get asked, but it's still good to know, is what is a plus b cubed? There are 2 ways we can do this now, or 3. We can FOIL it out. No. We can use Pascal's triangle, or we can use the diagram method. So we'll do both. And then we're going to factorizing. So we're going from here, from these, backwards. We'll do that now. So we'll do this one, and then we'll go into factorizing. So what we're going for? Perfect. So we'll go a plus b cubed. Let's start with the rectangle. Just with the cube, I mean. This is a. This is b. Oops. This is a. This is b. Go down over here. Go down over here. This is a squared. This is ab. This is ab. This is b squared. All simple stuff we've done before. Then we're going to go and extend it by another ab. This is the same as saying a plus b, a plus b, a plus b. So we did a plus b and a plus b. We're going to extend it by one more a plus b. What happens if there are 4 there? You better hope you can look to the 4th dimension. Because you know what? I can't. I'm going to go a plus b again for all of these lines. Uh-oh, that's a little bit too much out, but it's fine. There we go. So this is A. Call this A here. We can call this B. That B extends all the way through. I'll do it again here on the bottom so it's easier to read. This is also A. Come on. Time to do it upside down and get it wrong. A, and this is B. Those are horrible, but it's fine. So what is, this is like a whole cube, it's like a Rubik's Cube now. A little less, it's 4 instead of 9. But it's like a Rubik's Cube. So there's still pieces inside that you can't see. Actually, you can see this one, you can see this one, you can see this one, you can see this one. You can see this one, and this one. There's one piece in there that you can't see. You can't forget about it. So what's this first piece's area? It's a squared times a, which is a cubed, plus, in the second piece's area, a squared times b, a squared b, plus this piece's area, ab times a squared b, plus the piece you can't see area, which is ab times b, which is ab squared, and then it's ab times a, which is plus a squared b, then plus ab times b, which is plus ab squared, and then plus b squared times a, which is plus ab squared, and then we add in the final b squared times b, or b, whichever one you use, b So it's b cubed. And finally, we just add up all the like terms, which is a cubed. We have 1a squared b here, another a squared b here, another a squared b here, which is plus 3a squared b. Then we have ab squared here, we have an ab squared here, we have an ab squared there, so it's plus 3ab squared, and then it's plus b cubed. And that is the answer for that. Really? Not that impressive. It's very unsatisfying to get an answer like this. It's like, what the fuck is this? What's this ever going to help me with? Fucking bunch of numbers and letters and not even nothing simplifies into a beautiful little cube. But by the way, this is interesting. Let's erase all this stuff. Leave the answer. And leave the question. There was some smart mathematician called Pascal. He had a triangle. It started with a 1. And then you add up the two terms and you put it in the middle. So imagine the two zeros next to the 1. You put a 1 there and a 1 there, so there's 0 there. It's like a face, but it's fine. Then we add up the zeros around here. So the 0 and a 1 give us a 1. 0 and a 1 give us a 1. Right in the middle we get a 2. And then once again, we put a 1 on the outside, 1 on the outside. 1 and 2 gives us 3. And between 1 gives us 3. Yeah, and every time it's around it's going to focus, so it's fine. I don't really care. Okay. And then 1 and 3, it's 1, 4, 6, 4, 1. Now you're basically asking me, what the hell are these numbers? You've got 1s, you've got 1, 2 1s, you've got 1, 3, 3 1s, and 1, 4, 6, 4 1s. I'd love to have a phone number like this, but what the hell is it going to help me with maths? Let's see. What are the coefficients of the numbers down here? Well, we have 1, 3, 3, 1. Interesting. What about this? What are the coefficients here? 1, 2, 1. Interesting. Now what do you assume the coefficients will be if instead of a 2 here, or a 3 here, we had a 4? I say it's highly probable it's 1, 4, 6, 4, 1. But what are the exponents and what are the numbers? Here's the trick. You see here how the numbers 2? We have 2 A's. 2 A's that appear. Number 3, we have 3 A's, 1, 2, 3. Also numbers 4, what do we get? Well, we get this. We get 1A plus another A plus another A plus another A. That's 4. How many B's do we have? Well, we have 1 B. We leave the A by itself, remember? There's always one A that's alone. We have 1 B, 1 B, 1 B, and another B. By the way, 4 B's as well. What are the coefficients? Well, we can go this way. 1, 2, 3. Exponents, not coefficients, exponents. 1, 2, 3, 4. Exponents for the B's. 1, 2, 3, 4. They're just going up in descending and ascending order. By the way, it's 0 and that's 0 over there. That's fine. It is B. So, those are all of those.